a few new modules. One of them is a prescaler for my frequency counter. Very simple prescaler, just a module that I bought and put a front in it. It's based on a MB506 and they go from 50 MHz to 2.4 GHz. So that's the claim. I tested it up to 2.34 GHz without any issues. So that's close enough, I think. Just a module that I bought. A little bit of a warning, there are several versions around and there seems to be some issues with some of them. So make sure if you buy them that you check out the reviews and the possible fixes. It's very weird. There's a diode D1 on some of the boards. It's not there. It's replaced by a 0 ohm resistor. And on other boards, there's something that looks like a capacitor, but I'm not sure if it is a capacitor, because then the board would not work. Some people claim the board does not work. And I've seen some pictures of people having it working with that component in that place. So again, R4 resistor in the output circuit. Some of them claim that it's not grounded on one side, it's just floating, it needs to be grounded. So I don't know what happens, since we different vendors, maybe different revisions of the board. So check out the reviews if you buy something like that. Another one I'm preparing, another board that I bought, high frequency noise. I have a noise generator here for audio, and this is one for high frequency. So in combination with my spectrum analyzer, that has no tracking generator, I can use this to do a quick check of filter circuits and so on. So that will be one of the next modules in here. And another one I made is a thermal camera. Let's turn it on. There's the menu, all the features, and here we have it. So a thermal camera with an external sensor. So I have a nice thermal camera, but you know what? Every time I need it quickly, the battery is empty. So I have to wait for the battery to recharge before I can really use it. So 1 meter cable, nice and handy sensor. So I'm just gonna use it now. Just show my hand here. Based on a sensor from Melexis, I had a few challenges with this one. The sensor itself, manufacturing, not up to par, I think, because they allow up to 4 defective pixels, non-consecutive. And you need to work around those. You need an interpolator surrounding pixels to get rid of those. They do provide a library on GitHub, but there's an issue with that. They don't do a good revision control. They made some changes. They are documented in a PDF file, but there's no version control numbering or anything, so you don't know what you have. And other people implemented libraries like Adafruit. They have a nice library which is just a wrapper around this, and they implemented. Well, they have the version with the routine to cope with the defective sensors, but they did not implement it in their wrapper, and it's not accessible externally. So I couldn't use it. Some others made a wrapper, but of an older version that did not have the routine to cope with the dead pixels. So I had to go from scratch and use the driver as is. They also don't provide the I2C driver part, because that's specific for the CPU. So they provide only the H file, the include file with the function that you should cover. Luckily that has been done by others, so I use that. Melexis, they don't seem to actively monitor that library anymore. It's dated 2017, and a lot of remarks and questions and bug reports, and maybe the guy who put it there no longer works there, so nobody is watching it. So that's a bit of a shame for a large company like that. Apart from that, it's working fine. I implemented a few color scales. With the encoder button, I can switch the interpolation on and off. Let's put it back on again. And I can change the color scale. So I have 16 color scales up here. I'll just go through them. All different color scales. Some of them a little bit different. Some of them a lot different. 16 in total. The way this been set up, you can add color scales if you want to. Very easily. It's just a lookup table with the color scales. I had some issues there. I found some nice color scales, but they are in a 8-bit, 3x8-bit format, and the display uses a 565 format. So that was a bit of a problem getting that sorted out. But eventually, yeah, it's working fine. I have the lowest and highest temperature here, and also have a crosshair cursor here, and have the temperature at the crosshair cursor, so I can just move around and go to the point that I want to focus on, and then read the temperature there. So that's about it. So nice. The thermal camera module. In front we have a 2.4-inch display, rotary encoder, and a connector to the sensor. On the bottom itself, not so much. ESP32. I usually use the room board, but I ran into some issues with memory, so I use the rover board, which has PS RAM. And as you can see, I had to make one change, one wire, because one of the pins, pin 17 was used, and you need that for the internal PS RAM. Apart from that, it's fully pin compatible with the other board. Apart from that, we have a little power circuit here, which I can turn on and off. It switches on the power to the entire I2C chain and the sensor as well. So if I don't need it, it's not powered on. The connection to the sensor, some terminators that I can remove. And this is the I2C repeater, because I have long wires going to the sensor, and that's not the intention of an I2C bus. But luckily there's a nice repeater for that. Works well, but it works on 5 volt, so we have level shifters up here to translate the I2C bus. So it works fine. I have optional a connection for a second rotary encoder, but I only used one because I don't have too many functions. The sensor board for the thermal camera. It's in a separate housing, very handy. I made this on my CNC, fully transparent. The cable is a special cable. It can withstand bending, it's shielded as well. The sensor, the Melexis sensor, is mounted on the back of the board. And on the other side we have the stabilizer here, because I need 5 volt for the repeater and I need 3 volt 3 for the sensor. So I have a 5 volt to 3 volt 3 stabilizer here. I have some level shifters here, the same as on the other board. And of course the same I2C repeater, because the sensor is just I2C on 3 volt 3. Works fine, I have no issues. I have about 1 meter cable, GX16 connector here. Yeah, no issues with the length of the cable so far, so that's working fine.